Look at the Earth. Isn't it beautiful? From space, it looks like a perfect marble. We see deep blue oceans, bright white polar ice caps, and lush, verdant green land. But there's some brown as well, where there aren't as many plants. These are Earth's sprawling deserts. But why are those specific parts of our Earth totally barren, and others incredibly green? I mean, deserts cover a massive chunk of Africa, and almost the entirety of Australia. But there's basically no desert in Europe. Why the difference? Europeans eventually discovered the answer, but they didn't find it by looking at the land. They found the answer in the most unlikely of places, the dangerous open oceans. Hundreds of years ago, early trade ships sailed from Europe, relying entirely on the wind. For days, strong trade winds pushed the ships enthusiastically southwest toward the equator. They were making great time, sailing beautifully across the sea. But then, suddenly, right near the equator, the winds would just completely die. The sails would go completely limp. The ships would stop moving entirely. The sailors called this dead, terrifying, windless zone the Doldrums. And for these sailors, being stuck in the Doldrums was a massive, dangerous pain. They could be trapped for weeks, baking under the hot sun, rapidly running out of food. The Doldrums were incredibly annoying for sailors, but they also severely annoyed scientists. Brilliant minds like Galileo, Johannes Kepler, and Edmond Halley all had competing, confusing theories about why the wind blew to the southwest. Did the wind somehow magically follow the sun across the sky from morning till night? Or maybe the wind simply had trouble keeping up with the ground, spinning rapidly beneath it. In 1735, a London lawyer and amateur meteorologist named George Hadley came up with an even brighter, world-changing idea. His idea ultimately helped explain not just the confusing ocean winds, but also exactly why our planet has thick rainforests in a belt near the equator, and bone-dry deserts just north and south of that tropical belt. Hadley figured that, since the sun blasts directly down on the middle of the Earth, it warms the Earth the absolute most right at the equator. This means the air to the north and south of the equator must be much cooler. And because that air is cooler, it is therefore much more dense and heavy. Think about how freezing cold winter air rushes inside when you open your front door. In the exact same way, the cool, dense air north and south of the equator must aggressively flow toward the warm, rising air in the middle. And as that cool air rushes in, it brings the trade winds and the sailors with it. But wait, what happens to the wind when it reaches the Doldrums? There in the Doldrums, the air didn't actually stop moving at all. It just changed direction. It headed straight upwards into the sky. The intense heat at the equator caused the warm air to rise rapidly, making way for the dense, cool air flowing in violently from both sides. And here is exactly where the Earth's beautiful greens and browns come in. As that warm, incredibly humid air at the equator rises high into the sky, it begins to cool down very rapidly in the upper atmosphere. And since cool air simply cannot hold as much moisture as warm air, it starts to rain a lot. It dumps enough endless water to create the massive, lush tropical rainforests. After reaching an altitude of about 17 kilometers, the rising, drying air hits the stratosphere. The stratosphere acts kind of like a solid ceiling, blocking it from going higher. This forces the warm air to spread out sideways and separate. Some of it goes far north, and some of it goes far south. As the air travels away from the equator, it rains away its absolute last drops of moisture. Becoming denser and slightly cooler, this totally dry air finally sinks back down. When this bone-dry air violently hits the ground, it sucks away all moisture. This creates the arid bands, where many of the world's famous deserts lie. This giant, invisible atmospheric conveyor belt is officially called a Hadley Cell, and it is the singular reason we have both tropical rainforests and brutal deserts. It's a delicate, beautiful balance of physics and heat. So the locations of the greens and browns on our Earth aren't just random luck. They come courtesy of a whole lot of hot air,